This is unit number 5, video 10, molecular formula. Now that we know how to get an empirical formula, which is the lowest ratio of atoms in a compound, we're going to determine the molecular formula, which is the true ratio of atoms in a compound. As we said, ionic compounds are pretty much empirical formulas. So we won't really have a different molecular formula. There might be a few exceptions, but pretty much everything in ionic is going to be an empirical formula equal to molecular formula. But in molecules, it's not necessarily true. For something like water, it is true. The empirical formula and the molecular formula is H2O because the lowest ratio is already evident in the compound. But other compounds, it isn't. So what we're going to do is we have to be given the molecular weight or the molar mass of the true compound. It's the only way we're going to figure it. We use a mass spec or a mass spectrometer to determine that. So that's pretty universal throughout chemistry to have a mass spectrometer where you can determine the true weight of the compound. Once we know the true weight, the relationship between the empirical formula's weight and the molecular formula's weight will be a whole number. So what we're looking for is the ratio of the molar mass to, and we'll just call this the empirical mass. That's going to give us a multiplier. And that multiplier, we can multiply our empirical formula subscripts by, and we will have the true molecular formula. So let me do an example. Let's say we have C3H7. So we'll determine the molecular formula if the empirical formula equals C3H7 and the molar mass of the true compound is 86.2 grams per mole. So we want to know the molecular formula. If the empirical formula is C3H7, the molar mass of the true compound is 86.2. Well, what we're going to do is take C3H7 and determine the empirical mass. 3 times 12.01 is going to give us 36, and 7.07. So basically, we're going to get 43.1. So the molar mass of the empirical formula is 43.1. We call that the empirical mass. So now let's build a ratio. The true molar mass is 86.2. So the molar mass of the empirical compound is 43.1. These have to be a whole number here. So 86.2 divided by 43.1 equals 2. So our real compound is C 3 times 2, H 7 times 2, which is C6H14.